Hello and welcome to Eplan Spotlight. Our topic today is standardization. My name is Thomas Michels and I'm here with my dear colleague Anders Danas. Hi Anders.
Hi Thomas, nice to be here.
Nice to have you in the studio.
Thank you, appreciate it.
So, when it comes to this topic of standardization, to be honest, this is not a new topic. So this is somehow circling around when it comes to industrial automation, when we are looking at the ecosystem of industrial automation. And but this is also somehow, even if it's already there on the table for a long time, it still sounds like a challenge for customers and our users. And let's take this opportunity here in that spotlight to really have a look at the complete ecosystem of industrial automation. So for example, when we take the role of the engineers, of the maybe machine builders, of the system suppliers, what does that mean for them? On the other hand, when it comes, for example, from the operator point of view to these topics of service and maintenance, so we have this topic of digital maintenance, more digital, less paper. And finally, when we think about the interaction here, it's important that maybe now let's use this wording, that they have a common language, that they have an easy environment to collaborate, and then it's finally, of course, also this topic of supplier guidelines. But finally, behind all these topics here, this is this topic of standardization. So find a way to collaborate as easy as possible. But let's start really from the topic, from the core of the topic. So Anders, what is the reason why? Why standardization?
Well, Thomas, I would say it depends on really what kind of eyes you are using. If it's the operator perspective or if it's really the subcontractor's perspective. Let's start on the operator side. And as you know, from the operator, they are not only maintaining and utilizing the assets of one machine or multiple machines. It's a complete plant. And of course, as a complete plant, you need to think about various aspects like common safety aspects for the whole plant, but also the personal safety of the production staff that they need to think about. They also need, of course, to think about the high productivity of their plant. And of course, if there is mistakes or repairs, that they are reduced to the minimum. So for them, they always think about standardization of the concept of simplifying communication to their subcontractors and simplifying collaboration to their subcontractors. And this is really a key element for them to be able to assure that all machines and systems that they are investing into are utilizing the same type of technology, for example. And this is really to simplify for every field service engineer to manage the same type of HMIs, for example, in their plant or PLC systems. And of course, if you have completely different systems and for every machine, that would be an enormous challenge for the field system engineers to manage this. So when you think about the fact that you have, for example, a failure on one part of the line, which is utilizing a system which has a specific PLC system, in the next hour you are jumping to the beginning of the line and this part has a completely different PLC system. Of course, this creates a lot of challenges for them. So to harmonize and simplify this is really a key element. And of course, to have field system engineers that knows all the system requires really high training, of course. But of course, for a new engineer coming into that plant would be an enormous time to onboard as well, of course. So this is really, in the end of the day, from the operator perspective, to reduce the complexity within the plant to maintain and handle their systems altogether. On the other side, if you think from the subcontractor's point of view, they have slightly different, of course, view, because they are producing a machine, for example, in a line which they are not going to maintain in the next 10 or 20 years. So for them it's about efficiency, so utilizing standardization to ensure that they are able to reuse their engineering from machine to machine or plant to the next plant. And this is really to also have insurance that they are competitive in the market, and also, of course, as they are maybe having multiple engineers in their firm, that they are ensuring the same type of quality in every project, regardless who are involved. And this is also what standardization do for them, as two examples.
Okay. When we have a look at this list of benefits, that sounds quite reasonable, yeah? So there is a lot of added value in standardization, makes things easier, simplifies communication, collaboration, etc. So that is quite obvious, yeah, from the operator point of view, or as you mentioned, also from engineering departments. But the experience was made that when we talk to customers, when we have customer meetings on fairs and customer events, and also not only customers but prospects, when you make the first steps with ePlan and we address this topic of standardization, the first initial feedback is always, that's not possible for us because we have individual solutions for our customers, we have variants in our machines, we have modules, options, and we build every machine is quite special, yeah, is individual, yeah. So, yeah, is this true?
And that's of course true, Thomas. I also experienced the same meeting companies in most countries actually. So when you think from the very common view, they think very commonly from, let's say, a mechanical perspective. And when you think from a mechanical perspective, yes, the machine or plant or line, whatever they are manufacturing, it might be physically quite different, so to speak. However, when you look from the electrical engineering perspective and the controls design, well, in general, you have all the systems are quite the same. So of course, for every machine, you need a power supply. You will need some type of controls in sense of PLC. You will need some sensors. You will need some actors. Then the question is only about, for example, sizing. So what is the size of the motors or drives, or how many sensors do you have, or how many actors do you need? And of course this determines, however, if you look from an electrical perspective, that you can actually standardize, because you can, from a graphical perspective, not see a difference if the motor is 5 kilowatt, for example, or 10 kilowatt. And of course this makes only in the back logics what kind of part numbers I need, what kind of motor overload drive I need, for example, what cable sizing do I need, which has no graphical aspect, but it has a big impact, of course, on the data behind it. But this is something that you can standardize and build typicals around to really be able to standardize your engineering.
So that I think is an important aspect, to think about the difference in between mechanical and electrical and the more functional view of the electrical, let's call it schematics, yeah, the 2D drawings to define the automation system, and to maybe put these glasses on and think a little bit different. But on the other hand, of course, you have to follow global standards, official standards, yeah, in the different markets. We have IEC, NFPA, whatever is valid for the special regions, or maybe for the interaction between the operators and the subcontractors. So are these standards driving the idea of standardization?
Yeah, definitely. So when you look from functional engineering to what traditional is called production-oriented engineering, which is when you can say, for example, production-oriented is where you find, for example, the engineering done based on not the function what the system are doing, but rather where you're looking on a hardware perspective. So you look at the PLC input card and you put that on the one page, and then you put the output card on the next page, and so on and so forth. And of course, when you look from a functional aspect, you put actually every aspect of that controls in one page. If that is the motor drive, for example, you need the input, for example, you need the output, and this is all then connected to the same page. Yeah.
So we talked now a lot. I opened the topic. I said the functional view, then you stepped in functional engineering. Can you go a little bit into detail what that really means?
Of course, Tomat. When we think about functional design, of course, we have to think about two different aspects. So traditionally, a lot of companies work with what we call production-oriented documentation. And this is more focusing on the hardware and how this is installed, like a PLC card you have on one page for the input, you have an output on the next page, and you are linking up your sensors and valves and so on and so forth. However, from an reusability perspective, this is not really efficient. And when you think from an engineering perspective, most engineers, they want to think about how the components are connected in the design. And this is exactly what the IEC 81346 is doing. It's focusing on the function itself and not on the hardware. So if you think about the picture that we are now looking at, we have three major aspects that we think about. On one side, we look at the object from what it does based on the function itself. On the other side, we think about the location, and that means, of course, based on where this now function is placed on the machine or plant. And last but not least, what is the product? What is it build? What is it doing, so to speak, itself? And based on these three elements, I can very easily structure my function in that standard and in my documentation. To structure it further, we normally also apply a fourth aspect, and that's the IEC 61355, which is determine the documentation structure. And the documentation structure determines different aspects of my project itself. If we think first about, if you look at the screen here, we look from a pumping function. We can also see how this have then different, let's say, sub-functions, looking to the safety, for example, to the switches that is necessary, and various connections and so on and so forth. And this is giving, let's say, a grouped view on a functional design. If we then think about the last and fourth aspect that I mentioned, which is documentation structure, this also helps to document the project in different aspects. So as we look now on the screen, we also see some examples of how you can easily determine, if I'm looking at documentation for controls design, electrical controls design, if it's a cable diagram, a fluid diagram, or a parts list, for example. And of course, this helps a lot when it comes to the structuring aspect as well. So let me also show you maybe another aspect which is important when you're talking about documentation and reusability and documentation. And what is important when you're talking about the naming convention is also cross-trade, because normally when you think about a project, you need them for example, not only to having electrical controls design, but you also need pneumatic design, for example. So you are controlling certain cylinders, for example, based on air. And of course, based on that documentation, you need to think about the cross-trade within the same project. And traditionally in, let's say, old standards, this is not really considered because that was not necessarily supported based on the engineering systems available. However, with the IEC 81346, we think, of course, based on all the cross-trades that you need to have and document within the same system. And as you know, based on the Eplan platform, we have multiple different engineering disciplines that we are utilizing in our engineering platform. So to just take the example of fluid design, utilizing Eplan Fluid, and also electrical controls design using Eplan Electric P8, here is an idea of how you can see how the project capsulating both engineering standards using the IEC 81346 to also have the same naming convention. And this is something that is getting more and more important, and that's one additional reason why more and more engineers and more companies are changing from the traditional, let's say, production-oriented documentation to a more functional-oriented documentation. So maybe just to give you a little bit inside the software, just so you can get a feeling how it looks inside the Eplan platform. So let's switch over to the Eplan platform and have a look. So on the left side, you can see now one of the industry samples that we have provided from Eplan. We see the project, and here we see also the first structure. This is what we are looking at right now, is the IEC 61355, which is, as I mentioned earlier, is related to the documentation structures. And here, for example, I can very easily find, for example, the documentations which is related to electrical controls design. This was the EFS, for example. We can, based on the structure below, we can see the plus, which was the location. In this case, we see that this is then located for the enclosure 1. And we see also here, for example, the function, which is related to a 400-volt supply. And based on this, I can then open the page, and I directly find all related components related to that power supply. So this is how you can see, in a very simple way, how you're replicating both the IEC 61355 for the documentation structuring, but also the functional aspect of the documentation related also to the IEC 81346.
Okay, so you introduced these, from my point of view, or maybe in the market, it's and you said that customers are more and more switching to these new standards and these very powerful standards that really support this idea of functional engineering. But when we look back, there is a traditional way to create documentation, and of course there is a reason why. So is this argumentation for production-oriented documentation still valid?
It's an interesting aspect, of course, Thomas, because obviously we are faced with this question time and time again, because of course the legacy aspect is always an important factor, but also the legacy is also built on systems that was not really supporting functional design. And this means, for example, just to take an example, so in the typical hardware design or production design aspect, you had to go through a lot of different papers to find the same information to that function. On the other side, today, when you do it in functional design, actually this is not at all necessary, because in Eplan, you have the ability to create all the data you need to collect all the information for the manufacturing. If that is then related to, for example, wiring or to any other aspects in the panel, this can be collected out of all the functions. So that means that the engineers can now support both the requirement on the manufacturing floor as well as the end customer, the operator, that is requiring a documentation which is much easier to rely on when it comes to repairs and maintenance, so to speak.
Okay. So that is somehow maybe a change from the view to this documentation, to this electrical documentation, to have all the information in that functional structure in the schematics, and then derive it to prepare it for the target group. Yeah, so to extract a wiring list, to extract a bill of material, and have all these different views, but one source for this information, and this source is easy to engineer, so to say.
That's correct.
Now, we started with talking about the ecosystem, and within the ecosystem the operator plays a major role because he's the order party. Yeah, so he is asking for machines, and of course it's then also demanding for documentation. And how is the operator now able to share this? Maybe there's a template project, there are rules to do the engineering. What is the possibility to share this with the sub-suppliers? Yeah,
good question, Thomas. So of course, when we think about standardization, we normally talk about 3 different levels of standardization. So it's different operators have different requirements on their subcontractors. Of course, you have it from, let's call it basic standardizations in supplier guidelines, as we call them, to more enhanced and detailed requirements on their end. And if we start about the first level, what you're looking at here is the system level. And when you talk about the system level, it's more on what kind of software or documentation formats is required, what version do you need to deliver in, for example, how do you install it, how do you license it. So on a basic level, basically defining the standardization. For those who want to go further, they also talk about the layout guidelines. And this also means that you are going, let's say, more deeper into guiding the subcontractors to define a specific project structure, as an example. You want to have them in a specific device name structure. You want them to have specific graphics that they are using. And of course, based on this, you are guiding the subcontractors more and more to have a recognizable documentation or structured documentation that all their field engineers are familiar with. And normally when we go the furthest level, which is then design guidelines, we also go really deep into also the graphical design rules. It could be also even defining, for example, what predefined parts they are allowed to use in the projects. As I mentioned earlier, when you think about the operator, they want to be able to have maybe a store spare parts in their facility, and of course, instead of storing all manufacturers available on this earth, of course they want to structure and standardize to a certain maybe brands or specific systems that is well known by the field engineers. So this is normally where we talk about this 3 level of guidelines that operators work with towards their subcontractors.
Yeah. A takeaway when I have a look at these 3 steps, there's the idea behind that it's scalable. So the first steps are maybe some basic steps, but they already can have an effect. Yeah, when I just think about the system guidelines to standardize on a system so that you get the documentation based on ePlan, for example. You have these ePlan files coming from all the different sub-suppliers. That already has a great effect. And then, of course, I think the operator can move, can develop, and go more and more into detail and get more and more holistic definitions of how the engineering has to be done. And I think it's also a good idea to really get into collaboration and get into this work together with these sub-suppliers. And maybe even from the machine builder or from the supplier point of view, it could be interesting to really address these ideas into the direction of their order party, to think about, hey, how can we synchronize and really have a common understanding, and not maybe too late find out that they did not follow a standard in that project. Yeah, so that I think has both, added values for both parties. And what I took away is it is important to share the guidelines, maybe standards, data, and whatever. So now let's go maybe more to the feature level or to the function level. So what are the offerings from our portfolio to support this collaboration and sharing of data?
Well, Thomas, actually ePlan is utilizing the cloud, and we are utilizing various different cloud applications to support that process. And as you can see on top of our ePlan platform, you see various different applications that we are providing. Some are free and some are subscription. And as you can see on, for example, the eManage, this is the base tool to start sharing projects where, for example, the operator can very easily upload their standard and share with multiple different subcontractors. Equally, they can define the rights, of course, to what subcontractor gets what kind of information. They can, besides, of course, ePlan data, share any kind of documentation from Word or Excel or so on and so forth. And equally the same, the subcontractor can then upload their projects also to the eManage environment. So when you also look at, for example, a viewer aspect, so for those who doesn't have an ePlan license, they can of course still view the project. They can have a look onto the documentation, but they can also, as the project proceeds, you also maybe need to do some verification of the progress. And of course the ePlan viewer is then a perfect tool to go in, have a look into the documentation, and also for the ability to handle redlining. So where they identify, for example, mistakes into the documentation, they can redline it, mark it up, and also communicate back to the engineering itself. Another aspect, and I mentioned it earlier, where this operator actually provide a clear standard for their subcontractors to work with specific component manufacturers. They can even already predefine them and provide it through the eStock environment. And based on this, there is an approved parts list, so to speak, that every of the subcontractor can then work with, and they don't have to reinvent the wheel again by utilizing new parts into the documentation.
Okay. Is it possible to have a short look at the Eplan Cloud so that we get an idea?
Of course. So what we are looking at here is now the cloud environment, and as I mentioned here, we see, for example, the various apps in our environment. We also see my current projects that I'm working with. I also see various different guidelines and e-learnings provided by Eplan in this environment. But let's start with the eManage and open to have a look on the projects that it's currently here in my environment. And as you can see here, we have a tab which is defining the internal project, but also where we are defining the external project. So again, as I mentioned earlier, you can define different rights to specific locations to divide it between different subcontractors that you want to provide certain data with. And of course, when we look at the different projects, we can go in here and have a look where we see then the project details when it was created. We can download this to start working with this documentation. We also see here an example of a PDF, which is of course also possible to share together in between. And directly from here, I can, for example, also open my eView. And this is also directly accessing the project online without any licensing and directly going into the project documentation. And as we can see here on the left side, we see the same structuring referring to the same standards that I talked about earlier. We see the view of pages at the moment, but of course I can also see, for example, if it's a cabinet designed in a 3D environment with our Eplan Pro panel. You can also look from a device-oriented perspective, but I can also have a look on the redlinings, for example, that has been done in the project. But just to take an example, we were in earlier in the EFS area for documentation, which is electrical controls design. We can of course also see here different type of functions. We see the locations, and I can directly go into my documentation. You can also see here on the right side, this is where I can do my, for example, redlining. Based on the same, I can also then mark the area which is going to be marked and communicated that there is a change. And based on this, I can write the necessary information. I incorporate this. And of course, I can then communicate it back to the engineering company or subcontractor that it's actually doing this. So I have a direct link between the subcontractor and the operator working together simultaneously based on the data that is worked with. So this also shows a very quick view on the eView, but also maybe just jump back to also talking about the eStock, for example, as I mentioned earlier. And this is also an application directly here in the cloud environment. And this is where I can see, for example, it's directly opening up my parts on the left side. We see the general information, but I can also see the graphical macro that is available from a 3D perspective or a 2D perspective, and also a product picture. And this is also where I can see all the necessary technical information that I'm utilizing. And of course, this is also available for the engineer. So if I open Eplan again, I of course also find the Eplan Cloud here. And based on the Eplan Cloud, I can also find the eStock environment, where it's now opening up also all the same parts. So I can go and have a look. And based on the parts, I can also see the same part here to start working also with this terminal, for example. So as an operator, the different level and different solutions in the cloud can support, again, the collaboration together with the subcontractor and simplify communication and simplifying the management of the guidelines in between.
So Hannes, that was really a presentation and introduction of a very powerful, really let's call it an engineering environment. Yeah, we talked about these aspects, the benefits of standardization. We talked about the different aspects. So we have these design topics, the system topic. We have Then also these structuring topics coming from these standards. We talked about parts. Yeah, libraries are standardized so that you have a common basis to work together. And now we finally saw these services that support the communication between different departments. And now just the question that is popping up in my mind is when customers say, yes, we want to do, we say, okay, they can start, right? Even maybe better today than tomorrow. But there is, of course, a question coming up, okay, how is ePlan supporting in that topic of standardization and start to structure engineering? Maybe you can just summarize it in short words.
Yes, of course, Thomas. Yeah, I would say ePlan have multiple ways to support our customer in their journey. And I would like to mention a few of them here today. So I would like to start to promote our ePlan engineering standard. This is a fantastic opportunity to start with ePlan, not from scratch, but with really a lot of data, not only from best practices from different type of industries, but also from multiple different standards, including different type of typical drawing reports from the different type of industries, basic projects, and so on and so forth. Let me show you live where you find it, because you need to go to eplan.com. So as you can see now on the screen, this is where we were actually before when we looked in our cloud apps for eManage and eView and eStock and so on and so forth. And on the same location, you will scroll down and you will also find our ePlan engineering standard. So as we can go in here to discover more, we will find more information, what it is all about, but also you find our download page as well. Here we'll be able to find also on the left side how you can filter on different best practices or industry standard projects, for example, but also what type of norms that you're looking for the IEC, for example, or NFPA. And also here you will find every aspect from, as I said, basic projects from building automation, for example, or if you are in the machine building environment, you of course also find the same type of projects here. You find typical information from various also suppliers like Phoenix Contact, Rockwell and Siemens and so on and so forth. So here you find really a lot of information that really helps you to get started, where you have perfect standard with the highest quality that you can expect, also referring to standards like IEC 81346, as I mentioned earlier in the standardization phase. And here you can really find perfect reference project and best practice project from your industry and just download and start using. So this is one way, Thomas, that I would like to promote. Another way would be also, if you think from the operator perspective, as I mentioned earlier, they're important to ensure that your subcontractors are really aligned on your expectation, how you want the projects to be designed, how you want them to be also delivered, how you want them to qualify the quality that you are delivering, for example. And this is something that the operator is commonly doing also by creating what we call e-learning. So they are providing trainings to the subcontractor basically. And this is also something that ePlan provides to create for various operators that wants to educate and share and coach their subcontractors to do the design in their preferred way. And this is also something that you also find not only for, of course, the specific operator, but you find e-learnings also on the eplan.com environment. So if I start also the e-learning environment, this is also where you can filter on the different type of e-learnings. Of course, also here you find the update trainings that we provide, but also all the other specific information for Fluid, for example, or how to handle reports or how to handle multiple terminal, for example. So the e-learning environment is also something that we share to all our customers, of course, to get deeper knowledge in the ePlan environment and the ePlan platform. But also we help operators to specifically share how they want their design to look like and to be delivered and to be also trained to their subcontractors. To mention last tip would also be to promote our professional service organization. And this is, of course, where experienced consultant, coach, and help our customers to take the journeys and take the step-by-step implementation of their standardization and of course also building up their reusability to ensure efficient engineering in their design process. They also help, of course, operators to help them with the supplier guidelines to standardize. And of course, here in the portfolio of where you find on our homepage, where I'm currently looking, you will find multiple different approaches how we help our customers. Everything from standard personal coaching to where we promote, for example, consulting subscription, where you can, on a yearly basis, continuously educate your team to explore more and more of the power in the ePlan platform. So Thomas, these were 3 examples how ePlan helps the customer to take this journey into standardization and efficient engineering.
A very powerful package when we see it from the solutions, the data, the experience in the guidance, and then of course also the very flexible way to do it via e-learning, for example. But I will not miss to point also something out that the consulting team, you mentioned the experience in the consulting team and also the experience in these standards and norms. So they put together this small booklet here. And this is really a full description of what we talked about today. So standardization, following these norms, how to make the first steps into that topic. So this will be available for download from the ePlan homepage and really gives a compressed overview and enables the first steps into these topics. So thank you very much to the consulting team. They put all their know-how and experience in these some pages. So that's really helpful. So, before we come to the end of that session, Anders, I would say thank you very much for sharing all your knowledge, all your experience, and introducing these topics across all the options ePlan offers to make the first steps into standardization. Thank you very much for that.
Thank you, Thomas.
It was a pleasure to have you here.
Thank you.
But before we finally close, I think it's also important that we address further spotlights. So, you are also in other topics.
Yeah, for sure. And I would like to really promote our service and maintenance spotlight. So this is also looking more deeper into the operators world where the projects are, let's say, operational, and how they also look from a maintenance point of view into their assets. A second spotlight I would like to promote is also the new 2025 version. We're showing all the news, and of course this will be really cool to see.
Okay. And then I just add 2 more topics. When we go a little bit earlier into the engineering process, we talk about pre-planning, so all the things that are done in basic engineering, and then of course we show the continuity of the engineering process based on the ePlan engineering platform. And one topic, of course, is also the idea and our topic to have electric P8 when you do your schematic design and use the automation functions that are available in ePlan. So maybe get rid of all these manual tasks and really use the schematic to put all the data to describe the automation system, and then use functions like from scratch, auto connecting, report generation, and so on to make your engineering faster and raise the quality of the overall documentation. Okay, so very interesting topics. Again, thank you very much, Anders, and hope to see you in further spotlights. Thank you very much for your attention.
Thank you.